Hello, and welcome to the Cerberus PRO All Steps from Offering to Maintenance e-learning module. It is based on Introduction Package 7 and covers the functions and components of the international version. In this lesson, we will look at all the steps from offering to maintenance as a process. Offering process step. In this process step, you can assist your planners or architects with a simple online tool. The Spec Writer creates a system description of the entire Cerberus PRO fire protection system at the touch of a button. You can create the right system description from the very start. Planning process step. For the planning of your fire protection system, you can access the clearly designed planning tool or the detailed planning document. Check the system configuration with the Cerberus PRO Quantities tool. And finally, use the online version of the product catalog to find the order numbers. To wire the CNET, use a twisted two-wire cable with or without shielding. We recommend using unshielded cables as it simplifies installation and gets rid of the need to remove the shielding. Please make sure that the cable type you use complies with local regulations. Wire detector bases. Connect the negative and positive poles to the corresponding terminals in the detector base as shown in the graphic. You can connect the external alarm indicators to terminals 1A and 6 and freely configure how the external alarm indicator activates. It is possible to activate the indicators alongside the detector's internal alarm indicator, or using a zone alarm, or using an independent control. Each base is equipped with a loop contact, continuity switch. The continuity switch ensures that the loop remains unbroken when the detector is removed. Detector identification process step. Detector identification helps you to keep track of all CNET devices in the building. Each device has a globally unique ID number. This ID number is printed on the detector and also on the removable label. What is the next step? Stick the ID number onto the building plan before the detector is installed. This makes it clear where the detector is positioned. All CNET devices, from detectors to the I/O module, have a unique ID number. If all stickers are added to the building plan, the engineer knows exactly where each device is installed. You can then correctly link the detector to the right customer text using the ID number. Detector identification makes it safe and easy to assign customer text. Once all CNET devices are wired and the detectors have been installed, you can test all or part of the installation using the line tester. Possible errors in the wiring are displayed on the line tester and can be quickly located and easily corrected. If the line tester does not display any error messages and all devices are visible, the installation work step is complete. The line tester helps the installer to demonstrate a complete and functional loop, enabling a clear handover from the installer to the commissioning engineer. If desired, you can export your loop's hardware topology to a file on the PC at this point. For example, if the line is broken between detectors 6 and 7, the line tester displays an error. With the activation of the particular internal alarm indicator of the detectors, you can easily locate the open line and fix the issue. After the installation test, you can commission the Cerberus PRO panel. How can we go about this? There are 3 different ways to commission it: automatic configuration, configuration off-site, and configuration on-site. No matter which way you choose, you need to link up the hardware tree with the detection tree. What does this mean in practice? Remember that we already have specific information about the sensor and a unique serial number or ID in every device we use on the CNET. We mentioned this on a previous slide. The hardware tree on the tool displays the system's physical structure. We can see the order in which our loop is wired and which devices are connected to each other. The detection tree is where we set up our logical structure and assign single detectors later on. We use this to set up a more convenient user interface on the panels. The detection tree is independent from the detector wiring sequence and can be customized by the engineer. This brings us to the first step you have to do to pre-configure a panel program. Set up the detection tree and organize the fire control panel into areas, sections, and zones. This step must be completed for every site and is the same for off-site and on-site programming. After setting up the detection tree with the customer texts, you are ready for the next step, for which there are two different options. Option 1. Configuring the panel off-site in the office. To do this, we need some data from the site, which can be delivered online by your installer. They can use the line tester to create a data file. We also require the building plans complete with ID numbers. If we receive this information, we can configure the whole panel without being on site. Option 2. Here, we configure the panel on site. To do this, we read in the loop on the panel and upload this information to the PC. With the help of our building plan complete with ID numbers, we can now assign the IDs to the right zones. For larger sites, you can use a data matrix code scanner to assign the devices to the right zones by just scanning the data matrix code on the ID label. The scanner transmits the device ID automatically to the Cerberus engineering tool so they can be assigned quickly. But wait, wasn't there a third option? Yes, you are quite right. The third option involves using auto-configuration to configure a panel quickly. The fire detection system can be commissioned quickly and without using a software tool, using the auto-configuration feature. All devices are automatically configured, from detectors and alarm sounders to floor repeater terminals. How does it work? Which customer text is displayed on the alarm? Let's start at the beginning and use the CNAT loop command you have already learned about. The auto-configuration command is issued on the fire control panel. The panel is in normal mode. The system is ready to use in just one step. If a detector is now activated, the fire control panel displays the automatically generated customer text. In addition, the panel activates I/Os, sounders, floor repeater terminals, and remote transmission output. The automatically generated customer text is generated from the number of the installation sequence on the CNAT loop and the unique device ID number. After auto-configuration, you can change the configuration at any time using the Cerberus engineering tool. The building is protected right from the start with auto-configuration. Installation test process step. After commissioning, check the entire fire detection system is working correctly. You can use Cerberus PRO's installation test mode to help you do this. Activate the installation test mode on the fire control panel. This command activates the most sensitive parameter set in all automatic detectors. This makes testing more efficient because the detector can be triggered more rapidly. The programmed controllers and the outputs for remote transmission remain active and are integrated into the test process. Activate an optical detector with the test gas. The fire control panel displays the alarm, and you decide whether the customer text displayed is correct. Trigger the thermal detector with heat. The detector responds very quickly due to the sensitive parameters in the installation test mode. To activate and deactivate the manual call points, use dedicated tools such as the plastic key. Once you have checked all devices, complete the installation test by pressing a button. All detectors activate the originally configured parameter set, and the system is ready to use. You can quickly and efficiently test the entire fire detection system using the installation test mode. In this process step, we will show you the two remote function options which are available for maintenance. The first option: you are on site and in a dedicated TCP/IP network connected to the fire control panel. With the aid of Cerberus Remote or the Cerberus Engineering tool, you can remotely deactivate zones or change customer texts, for example. If the connection to the site is established via an untrustworthy network, a firewall as a zone boundary protection is needed to protect the C-web from unauthorized access. For further information, please read the FS720 Network Security Guidelines. The second option: you are connected to the fire control panel via the Internet. You can, for example, carry out precise diagnostics in the event of a fault from the office via a secure VPN connection to a router and a firewall. With this information, you can arrive on site already equipped with the proper spare parts. If the connection to the site is established via an untrustworthy network, a firewall as a zone boundary protection is needed to protect the C-web from unauthorized access. For further information, please read the FS720 Network Security Guidelines. The remote functions allow you to respond more quickly to customer needs at all times and from anywhere. In the next chapter, you will learn more about the topic documentation.